In this video, we're gonna learn how to solve first-order linear differential equations. Linear ordinary differential equation is of the form dy over dx plus p of xy equal to g of x. Given the equation y prime equal to 1 minus 2xy all over x squared, in which the initial condition is given that when x is equal to 1, y equal to 2, find the particular solution. The given equation seems a bit messy at first glance. So, what we're going to do is make some simplifications to make it simpler for us to solve. The first thing we'll do is divide this part into two terms. Thus, we have y prime equal to 1 over x squared minus 2xy over x squared. For this part right here, the x is cancelled in the numerator, so we are left with 1x in the denominator. We then transfer this term right here on the left side of our equation, so as to follow the general form for linear ordinary differential equation. Note that y prime is equal to dy over dx. And so we have dy over dx plus 2 over xy equal to 1 over x squared, where p of x is equal to 2 over x. Now that we have a value for p of x, we then find for the integrating factor. The integrating factor is something which could be a number or a variable that we multiply to both sides of our equation so as to make it integrable. Given the formula for integrating factor, f equal to e to the integral of p of x dx, we substitute the value for p of x equal to 2 over x. So we have f is equal to e to the integral of 2 over x dx. We take 2 out of the integral, and so we are left with f is equal to e to the 2 times the integral of dx over x. The integral of dx over x is ln of x. So we have e to the 2 ln of x. We bring the 2 up, and so we have e to the ln of x squared. E to the ln of x squared is same as x squared. So we have the value for our integrating factor, which is x squared. Now that we got our integrating factor, the next thing we should do is multiply this to both sides of our equation. The left-hand side of the equation is the same as the derivative of the integrating factor times the dependent variable y, while the right-hand side of the equation is just equal to 1, since x squared is cancelled. Now we integrate both sides. The integral of the derivative of x squared y is just equal to x squared y, while the integral of dx is x plus some constant c. Since we are given an initial condition that when x is equal to 1, y equal to 2, we substitute these values to this equation to get the value for constant c. Now that we have a value for c, we substitute it back, so we have x squared y equal to x plus 1. Now we only want y to be on this side of the equation. So what we're going to do is divide both sides by x squared, and so we are left with y equal to 1 over x plus 1 over x squared. This is now our particular solution. Thanks for listening and hope you learned from watching this video.